Welcome to A Handbook of Digital Logic by N.B. Singh. This book is designed specifically for absolute beginners who are eager to embark on a journey into the fascinating world of digital logic. In today's digital age, understanding the fundamentals of digital logic is crucial, whether you're a student, hobbyist, or aspiring professional in the field of technology. Digital logic forms the backbone of modern computing systems, from the devices we use daily to the advanced technologies shaping our future. This handbook aims to provide a gentle introduction to digital logic, presenting complex concepts in a clear and accessible manner. We've carefully structured the content to guide you step by step through the foundational principles, starting from the basics and gradually building your knowledge and confidence. Whether you're intrigued by the inner workings of computers, curious about how electronic circuits process information, or eager to explore emerging technologies like quantum computing and biocomputing, this handbook serves as your gateway to understanding the underlying principles. No prior knowledge of mathematics or electronics is required to dive into this book. Each concept is explained using plain language and illustrated with real-world examples to help you grasp the material easily. Throughout your journey, remember that learning is a process of discovery and growth. Embrace curiosity, ask questions, and don't hesitate to experiment with what you've learned. The world of digital logic is vast and full of exciting possibilities, and this handbook is your first step towards unlocking its potential. We hope you find A Handbook of Digital Logic both informative and enjoyable as you embark on this enlightening adventure. Let's begin our exploration of digital logic together. Happy reading. N.B. Singh. Boolean algebra and minimization techniques. Boolean algebra basics. Boolean algebra deals with binary variables and logic operations. Let's represent binary variables and logical not a, logical and A and B, logical OR A or B, Boolean identity A or not A equals 1, complementarity A and not A equals 0, De Morgan's laws not A or B equals not A and not B, not A and B equals not A or not B, idempotent law A or A equals A, absorption law A or AB equals A. Boolean algebra forms the foundation for digital logic design and circuit simplification. Understanding these basics is crucial for further exploration in the field. Boolean functions. Boolean functions are essential in digital logic, represented as functions of variables such as A, B, etc. Minterms and maxterms. Minterms and maxterms are expressions formed by the logical combinations of variables A and B. Minterm 0 represents the logical not of A and not of B, while maxterm 0 represents the logical OR of A and B. Minterm 1 represents the logical not of A and B, while maxterm 1 represents the logical OR of A and not of B. Minterm 2 represents the logical A and not of B, while maxterm 2 represents the logical not of A or B. Minterm 3 represents the logical A and B, while maxterm 3 represents the logical not of A and not of B.